Hello, everybody. How is it going? It is Sunday. It's currently 8 p.m. in Australia, in Sydney at the moment, and I'm so excited to be here again. Thank you so much for joining me. We're going to wait for a little while, of course, waiting for everyone to join. Um, Firstly, I'm really sorry that I had to move this 1 hour earlier compared to last week. I was just too amped after my hour from 9 o'clock Sydney time, and I found it really hard to sleep after. So I pushed it forward a little bit, and yeah, we'll see how this goes. Yeah, I'm really looking forward to today's session. Um, Thank you so much for your support throughout the week as well. I've had so many people message me saying thank you. Thank you so much for sharing some of your experiences and motivating me. I think it's so cool that I have the chance to actually motivate you as well. So thank you again. The pleasure is all mine. All right. I think we'll probably wait until 8:02 before I run through the rest of it. But yeah, we're gonna have a ton of Q&A today. I've prepared quite a lot of stuff on my iPad, so we're gonna see how that goes as well. Um, but yeah, just hang tight for a little while, and we'll wait until everyone comes online. And yeah, I hope you enjoyed today's session. Yeah, I realized it doesn't really. I still feel really nervous, even though I've done this last week. And I was much more nervous last week, but I'm just as nervous this week. So we'll see how it goes. All right. Mhm. Thanks, Abhishek. All right. I think yeah, let's get it started. Thank you so much for investing another hour of your time on a lovely Sunday to join me for episode 2 of Data with Danny, live personalized mentorship for data science and other data professionals. I'm really excited to be here to try and share some of my experiences with you again, and I really hope that you can take something out of this session. And I just want to have a really good time. I want everyone to have fun. Okay, so enough of the intro. Let's talk about exactly what we're going to go through today. So this week I spent a little bit of time preparing a scenario, a very common machine learning end-to-end example. This one will be quite interesting. I tried to sprinkle in a few fun things in there to try and keep it exciting. So we'll see how that goes. It's going to cover a lot of business problem solving, some experimentation, analysis and insights, some basic machine learning stuff, as well as some statistics. I can never really say that word quickly. But the main goal is to try and give you guys some sort of like a larger context of how one of the really common machine learning problems and how that kind of fits in, so you can see what we kind of do on a day-to-day basis, as well as kind of it's very different to everyone thinks of machine learning as like, oh, we do packages and all this other stuff. So yeah, hopefully you guys will get a bit more context out of it. And yeah, we're gonna do plenty of Q&A. I plan to kind of sprinkle it in throughout the iPad stuff with the machine learning example. So we'll just see how we go, and yeah, let's jump straight into it. And after all of that, I'm going to talk through the next steps for how we're going to progress with some of this mentorship. I've started preparing some stuff on the side, but yeah, we'll get to that later. All right, so I'm just going to switch to my iPad now. Wow, how does that look? Okay, so I kind of jumped the gun a little bit, but for today, we're gonna imagine that we're all employees of Amazon. We're working for Audible. So for the people who haven't heard of Audible before, it's sort of like a subscription service where you can. Oh, I need to speak a little bit louder. Okay, I'm gonna move the mic a little bit closer to me. Is that a bit better? Cool. No. All right. I'll leave it here. If I bump it and it messes up or something, I'm really sorry. But yeah, today we are all employees at Amazon. We work in Audible in the machine learning team as data scientists. So the main problem for today is pretty much Audible has a subscription service, and you you need to pay roughly $10 a month to kind of get one ebook or audiobook that you can listen to. And that kind of keeps going. So you can see that there's some dollars in here. All right. But the main issue with the Audible problem is that we also offer a 30-day free trial to customers. And a lot of customers end up canceling their trial after the 30 days, and we don't get this $10. So that's not good. In general, in the data science and machine learning and whatever, we normally call this problem a customer acquisition problem down here. The main things that we're trying to solve here is how do we increase our customer base? And also for us specifically, we really want to focus in on how do we measure the impact of our work. So all of that machine learning stuff that we're doing. Cool. So this is the general thing. Congratulations, everyone. You all work for Amazon now. Woohoo! Okay. So now that we have the general problem statement, let's take a look at what we generally see from management. All right. So this is, I don't know if you guys have seen this before in your current workplaces, but management, what do they want? Oh, whoops, that's a rubber. They want more money. Give me more customers, more sales, more everything. So let's say we did some data analysis and we actually looked at the customer base over time. And you can kind of see that it increases. I actually don't know how many customers Amazon Audible actually has, probably billions, but you get the point here. So sales keeps going up, customer base increases, and they pretty much want it to exponentially increase. Cool. So from this business problem solving scenario, how are we going to do this? It's such an open statement. How can we actually make this happen through some of the data and the machine learning and the analytics? This is our problem statement for today. Okay. So before we even think about how to solve the problem, we should start thinking about what sort of data sources we have. I hope you guys enjoy my drawings here. I had quite a lot of fun doing it. So you can see like this Kindle looks like the Kindle thing. Kindle is the ebook reader for people who haven't seen it before. You read books through it and you can kind of flip through pages and stuff. This is the mobile app. I tried to draw it really nicely. And here's also some online browsing. But when you think of data sources from Amazon, what comes to mind? Let's think of Audible. We'll go Audible first. So maybe we can see how many customers they've had join the Audible subscription service over time. So maybe we have some customer data. Maybe we also have what books have people purchased. Sorry for my bad handwriting. Maybe from the Audible, we can also see whether people look at reviews. What reviews are they looking at? Also, for our business problem, how do we increase the customer base for Audible? What we might be interested in is who cancels their free trial and who goes on to subscribe. Who goes on to subscribe. These are pretty important for us today in this example, but let's just continue with the other data sources to try and get a feel for what sort of insights that we can get from the data. So think of this as, for any machine learning and data science project, we do a ton of data analysis before we even do any machine learning. We do a lot of exploration. We try and figure out some hypotheses and insights that we can share before we just dive into the machine learning. So from the Kindle, so because the Audible is all about books, audiobooks to be specific, maybe we can infer something about the people who are likely to go on and subscribe with Audible. Maybe they have certain behaviors on the other platforms, so like the Kindle, that actually give us some insights. So we can think of, let's say Kindle. You can also see, oh, do they actually buy any books there? How often do they read? How often? Um, how many devices do they have? All these different things you can find from the data sets. And let's just imagine, because we're Amazon employees, we know everything about the data. So we can ask whatever questions we really want. Now let's think of Amazon shopping behavior. Maybe if you're buying some high value items such as iPads or MacBooks, I don't know. I'm just making these things up. Maybe some shopping behavior leads you to being more likely to actually go on and get an Audible subscription. And you can say the same thing for anything that happens on a mobile app. So maybe you like to use the mobile app a lot. There might be some correlation between people who use their mobile app a lot are also on their mobile a lot. So then they're likely to listen to Audible. But there's all sorts of different questions or hypotheses that you can kind of ask the data about your problem. Cool. How's everyone going so far? I haven't lost you on the examples and the data sources. But in a nutshell, what I want to emphasize on this one is there's lots and lots of data. Yep, that's the main point. And we can use a lot of this data to help inform our decisions, to help drive some insights, to actually just make the business take some sort of action, do some experiment to try and increase the sales. So then we can get to here. All right, next step. So we've done a lot of the data sources. Now let's think about what sort of insights and questions we can ask the data specifically about our problem. And what's our problem? We want customer acquisition. All right. So maybe some questions that you want to ask may be, what sort of marketing are we currently doing? Maybe we already have some digital campaigns. Maybe there's some pop-up banners on the website throughout the different places. Maybe we send you some push notification on a mobile phone. Who knows? There's a ton of stuff going on. Maybe there's emails. So, spoiler alert, we're going to be talking about email campaigns for today as well. But maybe emails, there are some emails going out. So we can kind of try and find out what is currently going on and how that impacts the current customer acquisition problem. So the next step would be, I don't know if this is a step, but it's just something that I've written down here. But for me, it's really important to understand what you don't know, especially when you have all the data and you want to find out more. So I don't think many other people think of it this way, but the way I think of it is, what are the known unknowns? So what are the things that we know that we can't measure right now? Most of the problems will be, usually they revolve around this area, because there are a ton of things that we can measure, but there are a ton of things that we can't. And we can kind of avoid these things they're kind of like red herrings. But maybe the known unknowns could be, I don't know, some weird stuff like, what are people Googling? I don't know if that's too abstract, but maybe there are some questions that management want to ask that we just don't know. But we can kind of figure out what are the questions that we can't ask the data is the important part that I'm trying to relate here. Okay, and let's say we've figured out what the unknowns are. Now we can think about options. What are the options? What options do we have to actually move the needle on our customer acquisition problem and help those sales go up? In my experience, usually there are too many options. It's very difficult purely because the problems are so open, and we can do a million different things, but no one really knows what's the right or the best thing to do. So usually when this is the case in a open-ended machine learning problem, we try to stick to what is simple, what has a good chance of working, and then you kind of build on that as well. So let's just imagine for our example, because we're working for Amazon, our management has actually given us a limited scope of what we can deal with. So in this case, let's say we have the restriction of we're only allowed to email customers, and we can only email 1 million of them. And we need to make sure that they're existing Amazon customers and they've never used Audible before. So we're trying to acquire them into the customer base. Some of the questions that we want to answer will be eligibility. Who can we actually contact with our emails? They might have in the campaign space, in the marketing campaign space, there's a lot of, we call them exclusion rules or different things that kind of filter out customers until we get the final thing that who we can actually target. Now, in terms of the targeting should be clearly we're not going to blast out 1 million emails to random people, because we should try and apply some smarts or analysis or some machine learning to try and figure out who exactly we should be targeting. And the last question that we want to think about is, how are we actually going to measure the dollar impact of what we're doing? All right. Any questions so far in the comments? How am I going? Have I lost anyone? Is it too abstract? I'm just going to have a sip of water as well. Okay. So now that we've been given some scope around what we're going to work on, how do we actually do this? And how does this kind of align with what we're doing with data science, data analytics, and machine learning? So I think it's really important to think like a customer. In this case, it's easier because we're thinking about a customer journey on, say, Audible, for example. Now, as Amazon employees, we also have, I think they get discounts on Audible. So let's just imagine that we're part of this email campaign. So let's say the email gets sent. So this is step number 1. Email gets sent today, for example. Now, email gets sent. I receive the email. I then open it. So I open the email. I see a link on there. I click it to start my free Audible trial, and then I successfully sign up for the trial. 30 days go by. So remember that 30 days is the trial period for what's where we can kind of listen to one audiobook for free before we have to pay $10 a month. And then at the end of 30 days, I don't cancel, and then I continue to be a subscriber. So it's the happy path. I'm a success. Now, I have a question here around, what about without an email? This is really important to think of it in this way. So I know that this is success in terms of the email campaign, but we should also think of success without the email campaign, because a lot of the time, that's the thing that we're going to have to compare against to actually measure the value of what we're doing. So I'm just going to run through this example really quickly. But without an email, what we're going to see is maybe you don't get these first 2 sections. There's no email open, there's no email send. So what someone could do is maybe they land up on the website, the Audible website, or on Amazon, one of the websites, and they click that link to start their free trial. So they still do the trial. And the 30 days also passes. They really enjoy reading their book, and then they decide to also subscribe. Now, I know this one, we talk about success in terms of the email campaign, but success in the machine learning world as well, this can kind of be like, if we didn't send an email campaign, what's the chance that someone is likely to go all the way through and actually subscribe without us sending them an email? So just keep this in mind. This is a very important concept for later. Okay, moving on from the success, I'm going to talk about experiment design. So this might look kind of crazy and very intimidating at first, but I'm going to try and simplify it for you guys. Now, when we think of, let's just focus on this part here. So the simple design. Now, when we think of an experiment, usually we're testing something. So in this case, I want you guys to think of a bad experiment. A bad experiment, you're not actually testing against anything. So for example, in our Amazon Audible example, we have all these customers coming here. Now with all the customers, we can apply those eligibility rules where we strip out some of the customers where we're not supposed to email. So do not email these guys. And some of them who we don't email fall out, and we get remaining with the eligible customers. Now with the eligible customers, let's say we actually did some insights work. We did some data analytics, and we figure out that there's a group of customers who are actually, they are very likely to make it all the way through and subscribe to Audible. Let's just imagine that the insight here is that these people have a Kindle. I don't know, maybe it's true, maybe it's not true, but let's just say that they have a Kindle, and that makes them really, really likely to go on and be a success after we send them an email. So let's just say that this was the first experiment. We can also, instead of doing the insight where we have the Kindle, maybe we also do a machine learning model which correctly identifies which customers we should be sending this email to based off historical data. And then that can also give us great results also. So the reason why I call this the simple design is when we do it this way and we go sequentially through this order, there's what are we really comparing against? Because we're targeting all the customers who we think are going to do the thing. And in the end, let's say we have like a 20% conversion rate. That's looks good, right? 20% conversion rate. Maybe there's like, I don't know, $3 million. We're looking pretty good to get a good bonus this year if our 20% conversion is that good. However, we don't really know whether it was the email that drove these customers to do something. We don't really know. Let's say we didn't send them an email. Were they likely to go on and take up the subscription anyway? So this is why we kind of, in reality, we like to run A/B tests. Think of it like we're running, have you heard of randomized control experiments, where you usually have, say you're doing some sort of drug experimentation for medicine, and you have one group where they call it the control group, and the other one is the treatment group, where you're actually going to give them some medicine and see if it improves their condition. So in the same way, what we're going to do with our Audible customers, or with our Amazon customers who don't yet have an Audible account, what we're going to do is, let's say we do the same thing. So we do the eligible customers. Then we're going to have a control group where we don't actually send them an email. We just kind of track them to make sure that we know who they are. And we also have some group of best customers here where we use our machine learning to actually identify who we should be sending an email to. Now, after this happens, what we're going to get is some sort of success rate for both of these groups of customers. So let's say for the best customers, maybe we get that 20% conversion rate, and we're doing really well. 20% is not too bad. Now, when we look at the random customers, what if their success rate was only 10%? So randomly, maybe 10% of customers have done the conversion, and they go through and they get their Audible account. So here's where the next step, when we run the experiment, we like to compare what happened. So we compare this group with this group, and you can see that we're now comparing 20% to that 10%. So in terms of the result of what we're doing with our experiment, usually we like to call this some uplift metric. People really get confused here. So I know that there's a 20% and a 10%. People can sometimes really get mixed up. So the uplift metric here could be 2 times uplift. It could also be 100% incremental sales. But in essence, we're trying to figure out the difference between that 20% and the 10%, and then figure out how much value did we actually drive with our work. That's the crux of what we want to do with the experimentation design. All right, I'm going to move on from this one. I don't know if that was really confusing or not, so please let me know in the comments if that was confusing and I need to brush through anything again. All right, how are we going in the comments? How are we going so far? I know that there's a lot of information in there and a lot of experimentation, and we haven't even got to the machine learning yet. So please let me know if I need to slow down or if there's any parts which you want me to cover again. But for now, we're going to continue as well. Okay. Now that we've done the experimentation design and the eligibility, let's talk about targeting. Now, for the targeting, this is very key. I've put like a big green thing here. I'm getting some questions. Let me just quickly go through here again. All right. So the method of going by not sending an email. Thank you so much for the question. I might actually go back to the slide before. I kind of messed up this slide already, but it's kind of confusing. Let me see what I can do with this. I might actually create a new page so we can go through. Okay. This is a blank page. And let's think of, so we start with our customers. Sorry, my handwriting is disgusting. Now, when we run an experiment, let's just don't worry about the emails and whatever. Let's just imagine that we're running some sort of experiment. Now, with the groups of customers, ideally we'd split them. So there are, let's say we have group A and group B, and we kind of let's just put 50% of our customers in group A and 50% in group B. Now, let's say for the experiment, we're going to apply some sort of treatment to group A. So in this case, we apply an email. We actually send them an email. And in group B, we don't do anything. So we kind of call them the control group. This way, when we run the experiment and we look at the results, we can kind of see what is the conversion if we sent an email versus what is the conversion if we did not send an email. So when we compare these two results, then we can kind of think of what is the uplift of sending an email, and hence what is the value of that email. I know the email is not necessarily the thing that it's not where we're adding a lot of value in terms of sending out an email is not so valuable. But where we do a lot of work in machine learning and data science is who should we be sending emails to? I'm going to be covering this in later on in this section, but I hope that really explains the control group methodology and how we can kind of measure the impact of at least some sort of treatment. Okay, hope that helps. I'm going to go back to where we were before in terms of targeting. Okay, let me gather my thoughts again. All right. with the targeting, one of the most important things is before we send out an email or any sort of experiment, we actually don't know how that experiment will perform in real life. So what we do is we like to take the historic data and we do some analysis on it. And that analysis could be rules based, like I was talking before. Maybe the person who has a Kindle is also very likely to start an Audible account. Um, think of the rules as like simply if else rules. If a customer has done this thing and they've also done that thing, maybe they're more likely to take it up, and we can kind of just craft out an experiment just with those customers. Now, for the second component is this is where we want to get to, is where instead of using if-else rules and lots of insights, we can kind of automatically do that with some machine learning or predictive modeling in like a black box approach. You can see my little drawing here. Now, here's where it'll get a bit more tricky for the people who aren't familiar with the machine learning and the data science and the predictive modeling. But I'm going to try my best to very simply explain it and demystify a lot of the magic. Because for me, when I was starting, the most difficult part was I had no idea what a model was. People would just say, we need to use machine learning and build a model. And I found the concept of what a model was very difficult to grasp. So hopefully I really want to try and help you guys understand that and get the context within this Amazon Audible example. Now with this one, I'm going to describe and talk about what actually is a model. Please let me know in the comments if I'm going too fast. I'll try and adjust my speed to try and help as many people as possible. So when we think of a model or a machine learning model or a data science model, predictive model, in this example, we're actually solving what's called a binary classification problem, where we're trying to find the probability of success of something. Usually we can express this in more mathematical terms as a function of, this is a function of x. And you might be asking yourself, what is x? Okay, so x is, do you remember when we went through all of those different data sources in here? So we have like the Audible books, the Kindle, the Amazon shopping behavior, the browsing behavior, the app behavior. All of those things is what we're thinking about when we talk about that f of x. The x is what we call in machine learning terms, we call that customer features. And people, you might hear feature engineering, feature pipelines, pre-processing. All of those things live within this area. So they're kind of like the data that we learn from to try and give us some value. In this case, the value is the probability of success, where this probability will lie between a value of 0 and 1, where 1 is kind of, think of it like 100%, and the 0 is 0%. Cool? All right. Oh, there's a question here about this insights by exploratory data analysis. This is a very, very good question. So if we go back to this one, where we're talking about this rules-based, insights-driven sort of thing, one of the initial steps before we even jump into the machine learning is usually to do this rule-based approach. So in terms of the descriptive analytics and the exploration and everything, usually what we'll do is, I'm going to flip back to the other screen, I'm really sorry. But when we have these customer features, a lot of people think of the exploratory data analysis as you kind of have like, you have this data set, and it's got lots and lots of rows. And you kind of want to look at the values that are in certain columns, and you want to do some visualization, maybe some summaries. And that's exactly what we would do to try and figure out what those rules are, what these rules based and the insights to actually help us with the business problem. And in this case, we also do a lot of exploratory analysis as part of the machine learning process also. I might cover this later, just before I lose my train of thought of where I was going with this model thing. But I hope that the exploratory analysis is very, very important in any phase of machine learning data analysis. So please don't forget to do it. I'm just going to grab a water here. All right. So back to the model. I've talked about how it's sort of like a function of customer features that pops us out a value between 0 and 1, or 0% to 100% in terms of the probability of success. And you can see here that I've got like, how do we define success? I think I created this before, so don't worry about them more on this later. We already talked about how do we define success. I don't know if you guys have forgotten, but in terms of the success, we thought of it like this way. So making sure that someone gets the email, they click through, they start the trial, and they subscribe. Now, here's where it gets kind of tricky. So in the historic data, did we actually send any emails? Let's just imagine that we haven't sent any emails. So the only way to get some insights around the success metric is to think about it without emails. And this is why this point is super, super important. And we can kind of allocate for the historic data when we do the machine learning. We can use the insights based off the data of the people who went to the website, they click the thing, they start the trial, and then they actually subscribe. These are the people who we classify as a success in our data. Okay, so I'm gonna flick back. Oh, have I confused anyone? Anyway, I'll see in the comments. So the model is essentially just some sort of f of x, where the x is customer features. And that will give us some probability score, probability of success. That's essentially what a model is, a machine learning model, in its very pure essence. So I know it still sounds really abstract, but I hope it gives you some sort of view of what's going on. To help with that, what I'm going to go through is we're going to go through two examples. So let's imagine that on the left-hand side here, we've got the perfect model. So the model is so good that you get 100% accuracy. What does that mean? So let's say the model, so here I've got model output. So this is that the f of x gives me something. That something is this model output. So if we actually had a perfect model, like a 100% perfect model, we can think of, let's use a highlighter. So if the model was really, really perfect, we'd get all the successes would be here. Each dot of my thing is a success. Let's say we have many, many successes in our data set. And they all kind of live within this 100%. Every single value of the success will be 100% coming out from the model of this f of x. Now let's think of the failures. So the people, or the examples in the data set which didn't have this success. So ideally, if the model was perfect, we'd get tons of people at this 0% output from the model. So you can see usually in problems like this, they're usually imbalanced. So there are many, many more negative cases. So in this case, the failures, than there are the successes. But if the model was perfect, it would essentially be there's only two different outputs. You would essentially have 0% and 100%. Or you can think of it as a label of 0 and a label of 1 only. These are the only outputs from a perfect model. Okay, now let's talk about reality, what actually happens. So in reality, the model is never really so perfect. You won't see all of the positive cases being at 100, and you won't see all of the negative cases being at 0. A model, there's a saying that usually goes, all models are wrong, only some are useful. So in this case, let's say our model, some of the successes are really good, and the model kind of does the right thing and puts them close to 100%. But maybe it kind of is not so accurate, and you kind of get the model output giving you something just over 50, and it's still a success. Maybe even you get some cases where the model says, "No, I don't think this is not a success based off the customer features. This X, this case is not a success. So I'm going to give it a really low score." Now, let's say for the failures, the model can also do the same thing. So it can say, oh, after looking at all of your X, the customer features, I really think that this example lives here. It's not very likely to succeed. But the model is going to get it wrong sometimes. So maybe there are some scores which are really high. Here, for example, where the model is telling you, oh, I predict that this will be a success, and it doesn't end up being a success. This reality is what we deal with. This is how models come out, and we will always get some score between 0 and 1. Sometimes it can be even within a smaller range. Sometimes you never really get anything which is so high, close to the 100%, depending on your data set as well. We'll talk about more of that later, but it's just something to keep in mind for now. Okay, how am I going? Any questions so far in the comments? If this is too confusing or anything doesn't make sense, please let me know and I'll try and answer the questions straight away. Otherwise, I'm going to move on to the next component. So in this slide, we kind of talk about the perfect model, what a perfect model looks like, and also in reality, what a model actually is. Okay. So I'm also going to talk about models in terms of predicted versus actual results. So the way we normally do it in machine learning as practitioners, we usually think of it as we like plotting a lot. So in this case, you can see that I've got actuals. So think of actuals as the probability of a success based off the real data. So everything on this left-hand side is based off reality. Now, everything on the x-axis is what my model is saying. So these are all the model scores. So you get the 0 to 100%. Now, here's where it might get a little bit tricky, but bear with me. You'll see that I talk about bucketing and averaging. So when we think of a model and when we use it to actually target customers in any campaign, for example, you can think of it as, let's say these are all the model scores from 0 to 100. You might have customers who are here, customers there should be a range of scores, and usually it looks something like this, or it depends on what machine learning tool you're using, but you kind of get some sort of distribution across the scores. What we like to do is we actually like to bucket them. So think of these different sections as the percentiles. So if I actually grouped all of these customers together and I kind of ranked them, so let's say there's 100 people who our model has scored, and you put them all in a line. So you have this guy, and he has the highest score, 100%. And the next guy, he has the second highest score of 99%, and so on, all the way down to the person who is unlikely to be a success, and they have 0%. So so this is the example for 100 people. Now let's say that there are 100,000 people. So instead of grouping it individually and ranking customers one by one, what we normally do is we bucket them into deciles. So in deciles, it will be every 10,000 customers. So you have 10,000 customers here as the first decile. You have the next 10,000 customers here as the second decile. And you go all the way down to the last 10,000 people. And that would be the 10th decile. What we do is we actually take the average of all of their scores that come out from the model. So normally we'll call this the average output from the first decile. Let's say, for example, this is 95%. This one maybe drops down to 80%, and all the way down to the last decile, maybe the last decile only has an average of 5%. Now these are the model outputs. The model outputs are these ones. What we also have from the data, we also have the reality of these 10,000 people, where we rank them based off the model outputs. So when we have those two different data sets, we can actually plot them on this chart of actual versus the predicted when we bucket them by, let's say, the deciles. So if we think of the rate here, so let's say when we go from that 95th percentile, so I go, here's the 95%. So my model is saying that it's 95%. And if it was a perfect model, it would actually lie on this line. So when it predicts that 95% of the top 10,000 people will actually be successful, in reality, it actually matches. And you can see that here, it's directly on that line. So this 95%. And that's why I've drawn this y equals x. So this is about like the level of math that you really need to actually get started into the machine learning. There's not too much. I hope it's not too challenging. But now let's plot the rest of those deciles. So there should be 10 of them. I don't know if I've lost count. And if it was a perfect model, it would actually lie directly on this y equals x plot. We call this a calibration plot. And you can kind of see here that I've written that there's optimistic and pessimistic areas as well. I think it might be a bit too much to go through right now, but in a nutshell, if your points are actually lying here, for example, so your model score, your predicted model score is actually higher than the actuals, then your model is predicting optimistically. So there's going to be there's less people who actually go on and be a success, as opposed to if your points were here, the model would be more pessimistic, where it's actually predicting lower than actually what reality is telling you. I don't know if that was too confusing, but yeah, I think so far this is really just think of it as actual versus predicted. We always think of that when we're talking about machine learning, especially for binary classification problems. Okay, so wow, that took a lot of time, much more time than I envisioned in my head. I think I don't know if I've lost a lot of people with what I'm talking about, but I might I'll I might just finish up with this perfect model thing, and then we might have to move it to next week because I've run out of time for more Q&A. Um, but in terms of, so let's say that we actually have this perfect model. Um, that's not really it from a machine learning perspective. We'll also have to talk about there's things such as the precision, the recall, the accuracy. All of these things are metrics that we're supposed to know for machine learning in terms of how we apply it. But the main thing is even though we need to know these metrics, the most important thing is how does this actually relate to the business problem? And the business problem is like, how do we get more subscribers? How do we get more subscribers to Audible? And the main thing is like a lot of the machine learning stuff that we covered, it's pretty cool and very interesting and very deep technical. But in the end, we still have to tie it back to what the business problem is. A lot of my material after this point in time will cover that, but I think honestly, I've kind of run out of time. I think, and I don't know how many of you are still following at this stage. It was quite tricky. It was actually really difficult for me to try and explain it in a really simple way. So I hope I did a good job. I think we'll probably have to move a lot of the rest of the problem to next week, unfortunately. But I'm really keen to do more Q&A. So let's just open up the floor for more any questions that I might be able to help you with. This whole machine learning example went differently in my head. I think I was wondering if I'd run out of material, but it took much longer than I really expected. So I'm really sorry about that. But yeah, if anyone has any questions that they'd like to ask, I'm gonna do some Q&A right now. So let's see. Oh, thank you so much for the encouragement, guys. It really, to me, it felt really confusing as well. So I think I need to maybe refine it a little bit before kind of going live next time. All right. So here's a question related to the topic. So in this model, when we discuss about probabilities, is it a naive Bayes model? So you might have noticed that I didn't talk about any algorithms and model types or anything. I did that on purpose because we can kind of think of that model as almost like a black box. You can kind of use whatever you want. In general, it's better to kind of keep it simple first. So we normally the rule of thumb is like you stick to using a logistic regression first, just to get a good baseline for what you're going to do. Then you can apply more advanced methods, maybe a random forest, some boosted trees. Maybe you can do some deep learning as well, but it's really important to kind of frame up the problem before you actually dive right into the machine learning. I hope that I conveyed that more today, but I kind of got lost in my own notes as well. Okay, I think let's go with this one. What kind of domain knowledge is required to be an e-commerce data scientist versus a financial data scientist? This is a really good question. I think for me, I've actually had some experience in working in finance as a financial data scientist as well. So I can talk a little bit more about it. What I found was in e-commerce and anything related to campaigns or digital or anything, the problems are usually, I would say, more stock standard. So the problem that we went through today in terms of having the binary classification problem where we're trying to drive sales and all that sort of stuff, you'll see it as a very common trend throughout nearly all e-commerce problems for data science. I think for finance, it's quite different. I would say that you need much more domain knowledge in terms of finance if you wanted to move into that area as a data scientist or a quant. Um, I think when I was working on my project for that one, I leaned really heavily on the guys that I was working with to kind of explain to me some of the different concepts. So I managed to upskill really quickly. But I believe if I had a better background in finance, I would have had a much easier time to actually learn easier. So I think for finance, you do need more domain knowledge for that one. But for e-commerce, the problems are relatively, I wouldn't say simple, but they're more stock standard. There'll be every now and then there'll be a challenging problem which requires more logical thinking. But in terms of the actual domain space, maybe some of the digital stuff you might need a bit more knowledge on in terms of the click-throughs and the funnels and different things. But apart from that, I personally think you can learn them really quickly. So it's not a big issue. All right. Karampal, I think I would love to do Saturday and Sunday, but I just don't know if I can actually do it, if I can prepare enough material to take you guys through everything. But yeah, today it seemed like we really ran out of time, and I think it's such a shame because I don't think I did a really good job of explaining everything. So we'll just see how it goes from here. Let's see. A clarification on actual versus predicted based off the example. This is a really good question. Personally, I think it's one of the more difficult concepts to grasp. So let me try and go back to the iPad and try to go through it. So I really made a mess of most of this one, but in a nutshell, when you think of I'm just going to start a new page. Okay. So when we think of the actual versus predicted, I think for the predicted part is relatively simple. It would be given your model, that f of x, for one specific customer, what is the output? That's the predicted. Now, at a single customer level or a single observation level, the actual will be, in this case, it's either it's a success or it's a fail. So when we think of it as like a one-to-one problem, it's pretty simple to compare this predicted value to either a success or a fail. But usually when we think of actual versus predicted, we think of it in buckets. So this is where we talk about the deciles or the percentiles. These things, when we think of the actuals and the predicted, we actually don't look at individual customers, but we bucket them into the top 10% or whatever. This would be the first decile, or the bottom 10%. And we kind of just like bundle those customers together, and we take the average of what the actual is. So in here, you might have, let's say 0.9, and it's a successful record. But when we look at it over a lot of customers, we will take the average of all of their predicted, and we'll also take the average of all of the success and the fail. So you might end up with, let's say for the top 10%, the average predicted may be, all right, let's say 95%. This is the predicted average. And the actual average, so when we look at the actuals, whether it was a success or a fail, maybe that one is a little bit lower and it doesn't perform as well. But yeah, I hope that helps a little bit. The main concept here is these buckets. So when we take the deciles and the percentiles, think of it as you literally just have everyone in a line, and you take the first 10% and then the second 10% until you get to the end. and you just get the averages of each bucket. Hope that makes sense. I'm going to go through another question. This is a really good one. Is it important to choose a domain when you're on a path to become a data scientist? This one is tricky because I think when a lot of people start their data science journey, they don't necessarily know enough about the domains to actually decide there and then that you want to become a data scientist in e-commerce, for example, versus finance. I think it's really good if you do have the knowledge and the drive to actually, let's say you really wanted to become an e-commerce data scientist, then that's really good. I just think it's not many people have that knowledge. Not many people will be at that stage where they know that they want to work in that area. I also think as you're upskilling and learning more about the machine learning, maybe your views will change in terms of what domain you actually want to work in. I found that personally as well. So I've worked quite a lot in like more retail finance. I've worked in e-commerce, some of the financial markets and stuff. And I'd really love to work within the health industry. I think using the machine learning in health to try and help people get better medicines, to do some of their like the disease prevention and all that stuff is so cool. And for me, I find it difficult because I personally don't have the domain knowledge to actually help myself move over to that area unless someone's willing to take a bet on me. So it's kind of tricky. And I think it's something that I think if you really believe that you want to move in that area, then nothing can really stop you. So I hope that gives you some more direction on that. Okay, let's see. I'm going to go through this question. Can you explain how classification as well as regression models work in real life? So I'm not sure if you mean in terms of how we use the output or in terms of how do we actually build the models in real life. The classification, we will normally use it to do this sort of problem where we're kind of, for the audible, we're trying to figure out who is going to be successful versus who is not going to be successful. I think you also see the classification in real life in terms of the really popular image stuff. So you might get all these different images, and the machine learning model or the neural network will tell you, oh, this is an image of a cat versus a dog versus an elephant, or different things. So that's classification is usually for classes. So either yes or no, dog, cat, elephant. That's more of the purpose of the classification. The regression models is more around predicting values. So let's say we're trying to predict the price of housing in Australia, which I think a lot of people try and do that. When you do the regression, it's more around you want to predict the value of the house price. Whilst if you, I think, yeah, when the model comes out, instead of giving you that probability value from the classification model between 0 and 1 with a percentage, you'll instead get a range of values up to whatever the house prices were that you input in your data. So it all depends on the target variable that you use to build your model, as well as the class of algorithms that you use. I'll hopefully cover more of that in the future. I think I might have bitten off more than I can chew in this session because it was much more difficult to go through so much. Okay. Anything else? Oh, this is a good question. In terms of backtesting for model validation, this is like a whole area that I could probably spend multiple sessions on talking about. I think you'll see a lot in current machine learning practices. People just they have their data set and then they'll use a lot of, they use like cross-validation or random splitting of their data set. What we normally focus on as machine learning practitioners is to craft out your data sets such that you can have very clear training, validation, and test sets. The most important thing is that you want to try and make the model work as well in production as possible. And the best way to do that is to make sure that your data matches to production data as close as possible. I know it sounds really vague and unclear at the moment. I really hope I can explain it in more depth in the future. It will take a lot longer than a few minutes just to talk about that right now. Okay. Oh, this is a good question as well. Sasi, how can we decide that the function f of x is well fit to the problem? This is where the actuals versus the predicted, using that calibration plot, the one that I showed before, is very useful. Some of the other metrics that I talked about also, like the precision, the AUC, and all those, the list of different things, they are also useful. But in general, what I want to stress is the metrics are they're good to know. Like, you should definitely know them if you want to be a more advanced machine learning practitioner. But the most important thing is, how do you tie those metrics back to the business problem? Unfortunately, we didn't get to cover it today, but I think that is a very important topic. You see a lot of people in data science and machine learning. They're very good technically at the problem of fitting the model, but they kind of, there's a disconnect when they try and reflect their results back to what it actually means to the business. And I think that's the most important part, because you can build the world's best model, but if you can't explain what you've built and how it's going to help whoever the person is that's going to make the decision, it kind of almost, you won't get anywhere with it, if that makes sense. So communication of your results and the technical component of the machine learning through and translating it to business is really valuable. I think that's a core skill. Okay. Let's see. How difficult is it for freshers to land a job or intern directly for data science and machine learning roles? I think it's very. I think it's almost down to luck. Unfortunately, it will be. You almost have to have the perfect storm of the places that you're applying for the internships and the graduate roles. They need to be open to having graduates join their machine learning and data science teams. That's one. Another one would be that they also, it depends what they're looking for as well. So let's say there's a team of machine learning people and they only want to hire people with a very strong software development background. If you don't have a strong software development background, unfortunately, it will be very difficult to make it in, purely because of their criteria that they're looking for. So it's almost down to luck in a sense at the moment, because there's no real clarity on what people are looking for. There's no real standards anywhere. So it's honestly, it's like the luck of the draw. So if I know it sounds kind of frustrating, but there are, what I want to stress is almost that even though there are lots of teams that are looking for very specific things, over time, what we'll see is there'll be more variety of people and teams that are looking for different type of people. So they might not necessarily need someone to have a really strong computer science background, and they're happy to kind of take someone who shows that they're very capable through their portfolio and their projects and different things. And I hope that that's where our industry will move towards in the future, where if you can show that you can do the work that needs to be done, that's all that really needs to be shared. You don't really need to have like a master's in data science or something like that to actually get a graduate role. I truly believe in that. So hopefully others will believe in the same thing, and then we'll see a lot more people moving into data science roles in the future. Okay. Yeah, I see. I get asked this quite a lot in terms of what courses should I be doing to get an opportunity as a data scientist. Unfortunately, I don't really want to recommend any one course, and I don't want to stop people from doing a specific course that they want to try. The most important thing for me is I think all the courses are great. and you'll definitely learn something from them. There might be some courses which are better for some people versus maybe it's the learning material, the way the presenter talks is very engaging for some, but it might not be the same for others. So I really encourage that you try and find exactly what sort of learning material works for you. But the most important thing is to document all the things that you're learning, so then you can share with the hiring managers and the people who are the gatekeepers for these entry data science roles. You need to show them that you have the skills. So I think just doing the courses and getting certificates, it's really good. The way to bridge the gap to actually get into those roles is to really focus on showcasing the skills that you've got and how they can help whichever team that you're going to join. So I hope that message goes through. Okay. Any other questions? I might do a few more questions and then I think that's it. I need to recover from trying to go through all this technical stuff and not doing such a great job of it. So cool. SR Productions. What are the most commonly used algorithms in financial services and banking, as well as trading industry? Um, I can talk about the financial services and the banking at a retail customer level. And in terms of the trading, there's all sorts of different stuff that are going on. So probably I can't talk so much about that. But in terms of the financial services and retail banking, most of the algorithms that we were using there are quite simple. In general, we would use probably boosted trees would be quite common. Either it's like XGBoost or LightGBM or any of those packages. Generally, we kind of just default to those sorts of algorithms as a first pass. Um, Usually, when we work in those areas where they're more mature, getting those customer features, they usually have pre-built tools that can just rip them out from wherever they live and bring them back at a customer level, and we can do further manipulations and experimentation with the feature engineering. But in general, we would spend a lot of time in crafting out the target variable, that success or the failure. I really wanted to go through that today, but I ran out of time. That's where my area of expertise is, in actually crafting it out and being able to test it and show that your model is working in a production environment. But I think yeah, in general, we would just use boosted trees. I think over time, probably as the deep learning becomes easier to use and integrate into production systems, a lot of those companies will move towards them because they can be more powerful and very useful. But yeah, I think in general, boosted methods and tree methods are a good place to start. Yeah, see how it goes from there. All right. Um, what are the skills required to get internships in the data science field? I think I've covered the last week in the live. There were, I think, 3 or 4 key skills which are required regardless of any level of data science. Let's see if I can remember them. There were problem solving skills, data analysis skills in at least a Excel. I also said good communication skills, and also I think I put SQL as a requirement as well. I think for a beginner data science role, it will be very good to actually find out for the companies that you're applying for, what sort of tooling are they using. If you know that they are very heavy R users, it would make sense to put more effort into learning R. If you know that they're very heavy Python users, you can do that as well. I think these days Python is becoming more widely used in data science at this stage, purely because it's not purely, but more that there's a lot of the machine learning tools in Python are quite mature now. R is still very good for data analysis, and I highly recommend anyone who's more focused on data visualization and analyzing the data to focus more on R. I think yeah, ideally, I'd love to say like, oh, try and learn both at the same time, but it's not that easy. It's a good challenge, I think, but honestly, it might be better just to focus on one language and then be quite proficient at that one and demonstrate your skills to the hiring managers to say, oh, I've learned this language. I believe that I can learn any other language that you throw at me, and I think that sort of confidence will come across quite well as well, as long as it's in an understated way, not going over the top. Okay, let's see. Ayush, do you think working in a consulting firm is good as it allows you to explore various domains? Um, I think for this reason, it's actually pretty good to be in consulting. Um, I think when I started off in a data role within a consulting firm, I actually didn't have a lot of variety. So I focused mostly on retail, like supermarkets style analysis. So I personally I didn't get so much variety in my early career, and then I went straight into a data science role with a bank. So I think for me personally, one of my mentors, like more not a data science mentor, but a career mentor, they would tell me if you really wanted to move roles or anything like that, try and move to either a different industry. So you're trying to cover more different domains through your experience. Tried to move into a different channel. So, for example, I used to work in a lot of email marketing campaigns, and then I moved into a digital area of the bank. So that was a nice little switch as well. And I went from supermarkets data to banking data, which was really interesting. But yeah, I think even without working in a consulting firm, you can still kind of get that natural experience working in different industries. Just the thing to note is that probably in a consulting firm, you might have less time spent on any certain industry unless you're going to specialize in it. Um, I can probably ask some of my friends who work in consulting as data scientists for more information. But I think that's generally how they do it, at least from my understanding anyway. Cool. Um, oh, there's a clustering question. I don't know if I can explain clustering in a very short amount of time, so I'll definitely keep it in for later. Um, yeah, I think I might have I might have had, let's see, no more questions coming through. Let's see. I can't really talk about these best grounds for the startups and stuff, unfortunately. But yeah, I think I've really had a good time today. I struggled a little bit trying to explain some of the concepts. I might need to really narrow down some of the things that I want to share on the iPad. I kind of was all over the place and the drawing was really messy. So I'm really sorry for that. But I hope for today you got some good value out of the iPad explanations. I have one more thing to cover as well, which was going to be next steps, which I totally forgot about until now. So I've started working on preparing a Slack platform for our community where we can all join in. And I think unfortunately it will be working on a free tier for now. So there are some limitations on how many messages will get stored. But at the moment, I'm just trying to figure out some of the logical sections that we can separate the channels into so we can have really good discussions about specific topics. I hope that it will go well. What I'm going to do is for the people who have worked on the survey and they've sent them through and I've got your emails, I'll be sending out an email link to join the Slack probably mid this week once I figure out exactly what I'm going to do with that. And yeah, I hope you guys will all join and we'll continue the discussion there. I really want to continue doing these lives as well. I'm not sure if I'm going to tackle more of these technical discussions on an iPad in so much depth. I might have to really figure out one specific thing and try to go through it. But I hope you guys really enjoyed today. I hope you learnt something, at least something small from me. And yeah, I had quite a fun time as well. So I'll see you guys later and really hope that you have a great weekend And thank you again for investing some of your weekend time with me. Thank you so much.